Hi, this is Barry Walsh, your COVID-19 Math 10 teacher online. Today we do systems of linear equations, the substitution method. Now before we start, I need to tell you that the graphing method, the substitution method, the elimination method, they all give you the same answer. It's a different way of doing the same thing. Some people prefer elimination over substitution. Other people prefer substitution over elimination. It's all up to you. But you need to know both. Usually, you do substitution with equations that don't have fractions, with equations that aren't complicated. Let me show you what I mean. This first equation, a typical equation, this one is more simplified. Why is it more simplified? Because x is by itself. X, we say, is isolated. Let me draw a line down here. So if you have a letter on one side of the equation, the left-hand side, say, just the letter, and everything else is on the right-hand side of the equation, it's perfect for substitution. Okay, so watch what I'm going to do. It says x is equal to 5y minus 47. So I'm going to put a circle around 5y minus 47. What does this 5y minus 47 equal? It equals x. So I can take this over into my other equation and substitute it in place of x. So I'm going to bring it down here. Negative 2x plus 3y equals 10. In place of x, we're not going to use x anymore. We're going to use 5y minus 47. So it's not going to be negative 2 times x. It's going to be negative 2 times 5y minus 47. Then we bring down the rest of the equation. So it's plus, and then 3y equals 10. What is the only thing different between this line and the second line here? The only thing that's different is that we have replaced x with what? 5y minus 47. Why do we replace x with 5y minus 47? Because in the equation that's simplified, it says x equals 5y minus 47. You see that? Well, how is that helpful? It's helpful because if you look at the second line, there's no x anymore. All we have is the letter y. It appears twice. But you know that when you have one variable with an equation, it's easy to solve. Okay, let's solve this. And we'll find out what y is. So first we have to multiply. Negative 2 times 5y is negative 10y. Negative 2 times negative 47 is plus 94. That looks right, doesn't it? I don't want to make any careless mistakes. I really don't like making those careless mistakes. I did these questions earlier, hoping to anticipate any problems that I might run into. But it's still possible to make mistakes. So I bring down the equal sign, bring down the 10. So what I have to do now is combine like terms. So we have negative 10y and 3y. Now if I add those together, I get negative 7y. Okay? And I'm going to bring this 94 down here. Plus 94 equals 10. How does that look now? We have only a very, very simple equation, so this should not be too bad. You need practice, that's why I have 3 examples that we're going to go through today. So we have plus 94, we have to move this over here. Opposite operation, the shortcut for opposite operation is when you bring the 94 across the equal sign, it changes to minus 94. Remember? Equals 10 minus 94 is negative 84. And I'm going to bring down minus 7y. Now we have to divide by the coefficient of y, which is negative 7. Both sides. Negative 7 divided by 7 is just y, or 1y. Negative 84 divided by negative 7 is 12. So there we go. We now have the first value of a variable, in this case, y. Okay? So you know from elimination what the second step is. The second step in the substitution method is the same as the second step in the elimination method. So you substitute, trying to spell these words right, substitute 12 for y in one of the equations. It doesn't matter which one. These are both pretty easy to work with. I think that one over here might be easier to work with. So x equals 5y minus 47. So the 12 goes in for y, right? Same as elimination for this second step. So I'm going to put x equals 5 times y. No, we're substituting 12 for y. So 12 subtract 47. X equals 5 times 12 is 60 minus 47. And what am I going to get here? X equals 60 minus 47. Is that 13? That looks like 13, doesn't it? Yeah, 13. So there we go. We have x and we have y. If we were to graph these, the ordered pair, the intersection point of the two lines would be 13 and 12. There we go. That's it. Now the only thing that you're going to have a little bit of trouble with at first is doing the substitution with the first equation. But I'm going to go through 2 more examples, and hopefully that'll be enough for you. Be patient. You know, when you're doing math, I know from my own experience, if I'm being patient, I can learn just about anything. But if I try to set a time limit, for example, if I say to myself, I'm going to learn this in 20 minutes, that's unrealistic. And I know that if I'm learning something new, it's going to take more than 20 minutes. I'm just talking about myself now. So when I put a time limit on myself, I make careless mistakes. I don't think clearly. So patience and not paying attention to the clock are really important. Okay, let's look at number 2. Now we could choose to work with either equation here. It doesn't matter. But we do not have x or y isolated. So what I'm going to do is I'm going to take this equation, the first equation, I'm going to isolate x. It would be harder to isolate y because we'd have to divide by 2. Why divide by 2 when we can work with x and we don't have to divide by anything? We just have to get x by itself. Okay, so let's bring this down here. X equals, if you take 2y across the equal sign, it becomes negative 2y, right? Opposite operation. Subtract 2y, subtract 2y. Now if we take the minus 37 across the equal sign, that changes to plus 37. Opposite operation. So now you can see that we have this isolated. And what I'm going to do is I'm going to take this and I'm going to put it in place of x in the other equation. Okay. So I'm going to bring the other equation down here. And I'm going to put x minus 5y equals negative 110. Now we know that x is equal to 2y plus 37. So I'm going to just replace x with negative 2y plus 37. What does that do for me? It gives me just one variable. One letter in an equation is easy to solve. So that's what we're going to do. It says x equals negative 2y plus 37, so we are going to replace x with negative 2y plus 37. And I'm going to bring down the minus sign, I'm going to bring down the 5y, bring down the equal sign, bring down the negative 110. What is the only thing that changes between this line and this line? The only thing that changes is this. Everything else is the same. Look, minus 5y, 5y, equals, negative 110, negative 110. The only thing that changes, we are substituting negative 2y plus 37 in place of x. So now we continue and find out the value of y as our first letter. All right, so we have negative 2y and negative 5y. That gives us negative 7y. We have to combine like terms here. Negative 2y and negative 5y is negative 7y. Plus 37 equals negative 110. That look okay? All right, as we're doing this, think about what the next step is. We have to take this 37 and move it over here. And when we do that, we get negative 110 minus 37. We do opposite operation with this 37, right? Plus 37 minus 37. Minus 37 over here. Now, I worked out this question this morning, and I couldn't find my mistake. And I'm going to tell you what I did. These are both negatives. I added them together, and what did I get? I got 137 negative. And it took me quite a while to figure out. I was tired, I think, and that was why I made that mistake. But it's minus 147. It just goes to show you sometimes you have to start all over again and find your mistake. Careless mistakes are so easy to make. Okay, so now we have negative 7y equals negative 147. Divide by negative 7 on both sides. And over here we get, when we divide, we get y, or 1y. And over here, 147 divided by 7 is 21. A negative divided by negative is a positive, so we get 21. Okay, so we're going to substitute, just like we did in the previous question, substitute 21 for y. And I'm going to use this equation. I could use either, but I'm going to use this one. So x minus 5y equals negative 110. So 21 goes in for y. So x minus 5 times 21 equals negative 110. Do you see what I'm doing there? I'm just replacing y with 21 because 21 is what we got for y. Okay, minus 5 times 21, that's 105, and it's negative, because a negative times a positive is a negative, equals negative 110. One last thing to do, and we are done this one. This 105, or negative 105, has to move over here. Opposite operation tells us we have to add. So x equals negative 110 plus 105. What does that equal to? Negative 5. So, if we graphed it, if we did it by elimination, we would get the same answer. Negative 5, 21 is the intersection point of the two lines. Okay, number 3. Now, if you look here, you can see that y is already isolated. It's by itself. So, what we have to do, we're going to take negative 3x plus 12, and we are going to put it in place of what? Y. And why are we doing that? Because the first equation says y equals negative 3x plus 12. So if y can be represented by negative 3x plus 12, then we can replace the y in this equation with negative 3x plus 12. All right, let's copy this down again. 5x plus 4y equals 27. Give me a little more room. So 5x plus 4 times negative 3x plus 12 equals 27. Now I'm going to emphasize this again, same as the last two questions. What's the difference between this line and this line? The only difference is that we have replaced y with negative 3x plus 12. Where did we get that? We got it up here because it says y equals negative 3x plus 12. Everything else in this line, in the second line, is the same as the first line. We just replaced y with negative 3x plus 12. And we only have one variable. And if we have one variable, we have an equation that we can solve. I'm going to do it in red this time. This is going to look like a Christmas tree. Anyway, 5x plus. Now we have to multiply. We have this 4 outside of a bracket or a parentheses. Students who took French in grade 9 are used to the word parentheses, right? So I'm saying that so everybody will know what I'm talking about. 4 times negative 3x is negative 12x. 4 times 12 is 48. That's supposed to be an 8. And then we bring down the equal sign and we bring down the 27. 5x and negative 12x. You add those, you get negative 7x. Those are like terms. Plus 48 equals 27. How's that? So what do you think our next step is here? We have to take the 48 to the other side because ultimately we want to get x by itself. So we'll have x equals a number. So negative 7x is equal to 27 minus or subtract 48. Opposite operation, plus 48 minus 48. 27 minus 48. So negative 7x is equal to, that looks like it's going to be negative 21. I think that's right. Yeah, negative 21. Our final step to find out the value of x is divide by negative 7. When you divide over here, you get x, or 1x, is equal to 3. There's our value of x. And our next step is the same second step as it is in elimination. So we have to substitute 3 for x in one of our equations. And this is it's not really complicated, but it's more complicated than this one. So I'm going to use the first equation. Y equals negative 3x plus 12. And we are going to put that 3 in place of x. Y equals negative 3 times 3. My brain got ahead of me here. So, okay, I'm going to cross that line out and do it again. Y equals negative 3 times 3 plus 12. Y equals negative 9 plus 12, and then y equals 3. So x and y are both equal to 3. And if you graphed this system of equations, the intersection point would be 3, 3. Okay, that's the substitution method. I have some practice questions for you today. So, as I usually say, why don't you stop the recording and take a picture of this with your phone. The answers are here, but they're not in order. And you need practice, guys. Elimination and substitution, they don't just happen. You get good at them by practicing. So please, please practice these questions. I was very careful. I worked these out 2 and 3 times to make sure the answers are correct, the answers I gave you. So I would like you to do them. If you need to contact me, you can do that, no problem. Barry Walsh at gmail.com. That'll get me Don't be hesitant. Don't think you're bothering me. I'm asking you to call me if you get stuck. So that's today's lesson. Have a great day, everybody.